Okay, we got maybe halfway done this morning. So section 1.2 continued. There are 3 reasons that limits fail to exist, which means they want me to find the limit as x approaches a certain number, and I can't. The answer would be does not exist. And one of those reasons is there's different left and right behavior. So this morning, as we approached, I think it was 1 from the left, we were getting really close to the value of 3. And as we approached 1 from the right, we were getting really close to the value of 3. So the left and the right agreed. Both sides were getting really close to 3. So we said the limit was 3. Well, this would be the left is approaching a number and the right is approaching a different number. Then we would say does not exist. The second reason would be an unbounded behavior. So you're looking at a function, and maybe it's a tangent line. You've got an asymptote right here, and you want the value, the limit, as x approaches pi over 2. Well, it's going up to infinity. And then remember, tangent picks up like this. So from the right, it's approaching positive infinity. From the left, it's approaching negative infinity. Well, even if they were both approaching positive infinity, what's infinity? Is it 200 billion? Is it 300 trillion? It's not approaching a number or a value, so it's unbounded, so it does not exist. And an oscillating behavior would be, it's the value's at 1, the value's at -1. It's at 1, it's -1. It's 1, it's -1. It's 1, it's -1. It goes back and forth, back and forth. That's does not exist also. Okay, here's our first example. We want to show that the limit as x approaches 0 of the absolute value of x over x does not exist. So let's think about this absolute value of x. Let's see, I didn't really mean to do that. So the absolute value of x is piecewise. It might equal x. It equals x as long as x is greater than or equal to 0. Like, what's the absolute value of 5? It's 5. What's the absolute value of 0? It's 0. But it equals -x when x is less than 0. What's the absolute value of -4? It's 4, so that's why we have that -x right there. So when you're thinking about the function, the absolute value of x over x, well, it's equal to itself. Absolute value of x over x would be just like x over x, which would be 1 when x is greater than or equal to 0. And absolute value of x over x would be -x over x, which would be -1 for x is less than 0. So we'd have this function here. The graph for all the values greater than or equal to 0 would be equal to 1. So we would be like this. And all the values less than 0 would be at -1. So that would be our graph. So 1 is obviously the point where we're having a problem. So, I'm sorry, 0 is the point where we're having a problem. That's where my graph splits. So what's the value? Well, as we get, let's look at 0 here. Here, as we get closer and closer to it from the left, we're at -1, -1, -1, -1, -1. But from the right, as we try to get closer and closer to it, we're following this piece of the function, and we're equal to 1, 1, 1, 1, 1. So we're approaching different values. From the left, we're approaching -1. From the right, it's +1. So the limit does not exist. Alrighty, let's do the next one. Example 4. Discuss the existence of the limit as x approaches 0 of 1 over x squared. Well, you know 0 is going to be the problem because you can't divide by 0. And if you plug this into your calculator, you get a graph that looks kind of like this. Like that. So there's actually an asymptote here at 0. We'd have an error message on our graph, on our table, when we looked at it. So let's go from the left and the right like we were doing just a second ago. So let's approach this 0 right here because the limit of x approaches 0. Let's approach 0 from the left. Well, it's maybe like 1 or 2, and then maybe like, I don't know, 8 or 10. I don't have any numbers on this grid. But where's it go? It goes all the way to infinity. Keeps going forever. Same thing on this side. Ooh, starting to increase a lot. We're going up to positive infinity. So even though both sides are agreeing and they're both going to infinity, who's to say what infinity is? So it's unbounded, so it does not exist. The reason is it's unbounded. Last one, final one, is the limit as x approaches 0 of the sine of 1 over x. And you would just want to put this into your calculator. And there's a great picture of it on page 51. I don't know if I can take a picture of it real quick. Let's see. Sorry. So I've kind of written over my work, but here we go. So what's the limit as x approaches 0? Well, you can see all this little back and forth stuff here. Back and forth, back and forth. So it's oscillating between -1 and +1. So since it oscillates, it does not exist. And if you look in your book, there's also a table that goes right along with this. And you can really see that oscillating behavior. 1, and then it's -1. It's 1, and it's -1. So, it does not exist.